But Landry, at the same time, I would challenge you though, right? What is a lot? A lot is a relative term, right? So it's really just kind of dependent on what you're trying to solve in the problem, right? But what is a lot? For some problems, a lot of data is 1,000 records. For other problems, 1,000 records is nothing, right? So keep that in mind. Keep that in mind. Yeah. Leo says that's why soft skills are also valuable. Yeah, absolutely. Thank you for that, Leo. Kago says one challenge could be we sometimes don't fully understand how the model arrives to its predictions. Yeah, yeah, yeah. Kago and Beecher, you're giving very similar answers, which is absolutely correct. Starry Vibes. It says local minima and saddle points. Yeah, absolutely. So we'll get to this a little bit later, but what Starry Vibes here is referring to is the process that a neural network goes to converge on an answer, right? The learning pattern, as we'll see later, of a neural network it's not linear, or it's not continuous. Is a better way to explain it. Just because it did good here doesn't mean it's always going to do well. It kind of goes in cycles, right? So the minimas and saddles that Starry Vibes is referring to is that until you do a lot of experiments over and over again, you never know if that network still has the possibility to increase its learning and its accuracy and all its metrics or not. You could just be in a saddle. You never know when you're actually at the network's final possible strength or minima until you do a lot of experiments, right? And in some cases, not all neural networks recover from those saddles. They kind of just stay there, right? And that's when you would have to play with more data or different types of nodes, different layers, so on and so forth. But it can be a little bit frustrating in that regard that you never really know when you're at the network's highest potential. But we're going to get to that a little bit later in the series. But thank you for that. Sorry, Vibes.